Hello guys, today I'm going to explain you a beautiful problem which is based on block and block problem. So it is based on friction. If you have done it, you must try this question. So I would recommend you to watch this video. If you are physics enthusiast, I would definitely recommend you to watch this video because I believe that you'll definitely be able to understand some new concepts and new things, new techniques to understand a particular concept in different ways. So I hope you'll get various things out of this video. So let's actually continue to see this video. So basically in this problem, a block is there and there is 2 kg block on top of 5 kg block, and we have applied a force of 4.9 newtons. I would try to keep my handwriting better, but I would highly I'll apologize for my handwriting because I feel it won't be better after at the end of the video, I feel. So basically force is 4.9 newton here, which is applied, and you just have to tell me that find. Okay, also the mu of this is equals to 0.2, and this is a smooth surface. It is a smooth surface which has mu of 0. So now find the acceleration of 2 and acceleration of 5. So you have to tell me that. I would highly recommend you to pause this video right now and try to solve it by yourself and come up with the answer. If you believe in yourself and your answer is correct, that you believe, you should actually write it in comment section below. So I'll see. First of all, what you have to do is you try to make the figure and try to actually analyze the situations. If for example it is pulled with force of 4.9 newton, this is a rough surface, so it will actually apply a friction force here, and that friction force, if we calculate, it will be 4 newton. How? Let me show you. It will be mu into, we don't know what friction is this right now, is it static or kinetic, but we know that the limiting value of static and the kinetic has the formula which is mu n. So mu n, and what will be n will be mg, and mg here, m will apply of the mass of 2 kg, because 2 kg is actually on the rough surface. So I'll just apply and write here it's 0.2 into 2 into 10, it will come out to be 4. So it's the 4 newton, means the friction force is 4. Now I'm rubbing it, you know that the friction is 4. So let me write it here. Yes, it is written. So friction is 4 here. Now for example, if you look at the FBD of 2 kg, the friction is applied in this direction, which is 4 newtons, and the force is applied in this direction, which is 4.9 newton. And if you calculate, then 2 into acceleration of 2 will come out to be 4.9 minus 4. So it will come out to be, acceleration will be 0.09. 0.9 divided by 2, it will definitely come out to be 0.45. You just wait with me till the end, you'll definitely be able to know something which is better. So wait till the end. Now let's try to find the 5 kg block's acceleration. So we know that nothing like force will be applied here because it's smooth surface, so no friction. So we know that normal, this ground will apply a normal here, it will apply 5g here, which is the weight mg, and the surface here also will apply a force normal here. So basically all the forces are vertical, they'll cancel each other because there's no movement in the vertical direction. Only the force will be here friction, which will be actually reaction force. Action has equal and opposite reaction, right? So there will be a friction here. So if I assume, because in the first situation we have already seen that the friction here, that the newton here force is actually 4.9 newtons, and the friction we got here was 4 newton. So if you assume, if you see here carefully, it was 4 newton, it is 4.9 newton. So if you see here very carefully, actually this is a wrong approach, I'll tell you, and I'll tell you the right approach also afterwards, but be patient, right? So basically this is 4 newton and this is 4.9 newton. You should actually watch this part also because it will actually enhance your understanding. So it will, if it is like this, then it means that there is actually a kinetic friction that is working, because it's kinetic friction is there. if you see here, the main force is 4.9 and the friction is this 4 Newton. That means the force is greater than the friction force. It means that it will be moving, and if it is moving, then the force of friction will be kinetic. So by keeping this understanding in our head, let's solve this. So basically, if it is kinetic friction which has a value of 4 Newton, so by that we know that the we can actually make the FBD of it. So only horizontal force is 4 Newton. So we'll write that 5 into acceleration of 5 will be equal to 4. That will come out to be, it will come out to be 4 upon 5, and that will come out to be definitely how much? 0.8. So this means that acceleration of 5 is 0.8, while the acceleration, if you have noticed, acceleration of 2 kg block was just 4.5. So it moves with acceleration of 5.8 Newton, sorry, 0.8 meter per second square, and this moves with acceleration of 0.45 meter per second square. What does this mean? This means that this block is moving faster. It means that the block of 2 kg will fall apart, or the block of 2 kg will fall behind the block of 5 kg. It will move faster. So if it is moving faster, what does this mean? And you also have to understand the friction is always essentially the kinetic friction which we are talking here, that actually opposes motion, right? Kinetic friction always and always opposes motion. So if it is up, if it opposes motion, and also one more thing, that it opposes relative motion. So it opposes relative acceleration, relative velocity. Wherever relative acceleration direction will be, that will be the direction of relative velocity, and we all know that relative velocity is opposed by the force of friction, force of kinetic friction. So here if you see, the relative acceleration for this block will be, means the acceleration of block with mass 2 kg with respect to the 5 kg block will be actually negative, right? You all know that because it has a greater value. So smaller value minus greater value will be actually negative, right? So if it is negative, which means that it is in left direction, so it is accelerating in left direction, which essentially means if kinetic friction opposes relative acceleration, it means the kinetic friction would have been was acting in actually right direction. So let me write here, the kinetic friction in this scenario, the kinetic friction in this scenario was acting in the right direction. So if I show you the block of 2 kg, so this means it was accelerating in this direction, and the kinetic friction was acting in this direction, which essentially means that the block was actually accelerating in left, though we had applied the force in right direction, which was actually equal to 4.9 Newton. How is it physically possible, guys? How is it physically possible for an object which was actually moved in right direction and it was moving in left direction? And these all things actually arrived by a wrong, contradictory assumption. And that assumption was due to the fact that we had assumed the friction to be kinetic. Yes, guys, assuming the friction to be kinetic was actually a wrong thing. Why? Because these all led to an unstable situation where we could not imagine a block which was accelerating in left direction even we have applied the force in right direction. It's not possible in this world, at least. So basically in this scenario we cannot do this, right? So now we have to assume that the force of friction was static. So let me again draw the figure. So basically the system is like this. It's 5 kg block, it's 2 kg block, and force of 4.9 is applied here. Now I assume that the force is static, and also let me tell you guys, in case of static friction, there can be two scenarios. First scenario can be when the whole system is at rest. You try to write the equation using laws of motion, and when you write the equation using laws of motion, you would equate the acceleration to be zero, or you would equate the acceleration to be zero and the net force to be zero, right? Because it was static friction. Or there could be any one case, or there could be another case where the relative acceleration is zero but there is system's acceleration, right? There is some system's acceleration which is not equal to zero, but the relative acceleration is zero. In that case also we can apply static friction. You write the laws of motion and you actually write it to some ma, which means some force, which is actually net force. So basically that was something extra which I wanted to tell you, because it was important to understand the situation. So now we all know that static friction is something that we have to apply in this situation, and by applying that, we know this whole system can be used or can be considered as combined free body. And if you try to see the forces on this body acting, there would be some vertical forces. I don't consider them, because actually the motion or the movement of the body of the whole combined body are not moving in any vertical direction, so I'll assume that it's only horizontal direction that is actually having those acceleration. So if you see that force will be 4.9, right? And this is the net force. So I would write the mass into acceleration will be the, which will be the net acceleration, that would be equal to the force, because it's the only force that is actually in the direction of acceleration only. So this means it will be 7, because the total mass is actually 7, so acceleration will be 0.7. That will be the correct answer. What does it mean? It means that the both of the objects, both the blocks of 2 kg and 5 kg are moving with the same acceleration, which is 0.7, right? Because of the contradictory way also we understand why we should take static friction and then solve it, which will actually lead to correct answer. I actually want to tell you something more. Yes, there is something more to it, and it's very beautiful. If you try to understand it in this way, that this is a 2 kg block, okay, and I'm in the frame of 5 kg block. I'm in the frame of 5 kg block. What does it mean? It means that we have to consider the acceleration of 5 kg in opposite to this, means we have to consider pseudo force. So basically if you consider pseudo force, it will be mass into acceleration of 5. We'll see what is acceleration of 5 later on, but it is acceleration of 5. And the forces, let me show it with black. The force here is static friction, right? The force here is static friction. Actually we should assume here it is kinetic friction, so that we can prove it was wrong. So the force here is kinetic friction, and the force here would be F is equals to 4.9 newtons, right? So if you try to solve it with this solution, let me also tell you one more thing, and that the 5 kg block was only moving with F is equals to, or with capital F, no, with small f only, right? It was moving with small f only, which was kinetic friction, that came out to be 4 newton, right? And this is 5 kg block. If you try to find the acceleration of the block, it will come out to be 4 by 5 and will come out to be 0.8 newton. So it will be 0.8 meter per second, right? Meter per second square. So this means acceleration of 5 kg block will be 0.8 meter per second square. Now coming to this position, now we have considered this is a kinetic friction, right? We are actually proving it wrong by using pseudo force concept. So it is kinetic friction, and this kinetic friction is equal to 4 newton. We have already done it. So now what I will do is, in this frame actually it is accelerating in opposite direction. It is accelerating with some acceleration. Let's say this is accelerating with this acceleration. So for example, this is 2 kg block, it is accelerating with A2, and what are the forces? It's 4.9 minus this 4 minus 2 into 0.8. So it will come out to be 0.9 minus 1.6, and it will come out to be how much? 16 minus 9 will be 7.7, right? 0.7 divided by 2, it will give us the acceleration of this, so it will come out to be minus, so it will be minus 0.35. So it will be minus 0.35 meter per second square. Now this you can understand one thing, very beautiful thing, that this particular block is actually moving in this direction, and this again contradicts very easily. You can understand this contradicts the scenario where we had actually pushed this block in right direction, it's moving in left direction. How is it physically possible? This is not possible, right? It's not possible. It's unstable situation, and this all instability arises when we assume it to be kinetic friction. So now I hope it makes sense to you why we have actually assumed it was static friction, and this is how all things goes there, and we have proved that it was static friction. Actually, one more thing is there that I want to mention here in this particular scenario as well. And what's that? Yes, this was the correct scenario. Now, if I actually assume that the acceleration is zero point 0.7 only, if I assume that the acceleration is zero point 0.7, I want to check whether it is correct or not. So, if I try to find using any of the blocks, if you use 2 block also, if you use 5 block also, if I try to find the friction and the friction comes in the range of its value, which means it should be smaller than 4, then will be confirmed that this force was static and our answer of acceleration is correct. So basically, let's check that it's 5 kg block, and the only force which is driving here into acceleration, it's the kinetic friction, I mean this static friction which we have assumed here. So it will be the static friction. So the static friction here, right, would be 5 kg into acceleration, so it will be 0.7, it will be 0.35, right? So it will be 0.35. So it will come out to be 0.35, as you can see, and 0.35 guys is less than, not equal to, less than 4 Newton. That was the friction in our scenario, and this friction, and it was actually limiting friction. If you have heard me right in the beginning, I told you that the mu s into n is the formula for limiting friction, and this limiting friction is 4 Newton, which is, and we have actually proved that the friction here in this scenario is actually less than point actually less than 4 Newton, which means that it's in the range, and it means it's static friction. It's not limiting, it's not kinetic, it's static friction only. So I hope all the things are clear now, and why we have, from starting we have assumed that the force was kinetic, but then we proved it was wrong, it is static friction. And then we somehow did our calculation, and finally we are at the point where we understand, we have beautiful clarity that why the friction is not kinetic and the friction is static. I hope this video added to your knowledge, and this video was very helpful to you guys. So let me know in the comment section below how you liked it, and thank you. Keep watching these videos. Bye.